what's going to happen in the long term. So as we look into the winter, let's look back this fall. Who remember, kind of had an idea of what happened this fall? Yes, the warmest fall on record. September records were obliterated across the state. We had one of the most anomalous areas of high pressure that set up over the Bering Sea in the first part of September. Some people were even saying it was the most anomalous weather pattern in the history of the Northern Hemisphere since records have been recorded, so since the early 20th century. So we are coming out of this incredible warm fall, warmest September on record in Anchorage. October, also the warmest October on record in Anchorage. So does that mean we're going to have a warm, horrible winter? Well, we'll see. So let's look at the some temperature and precipitation outlooks that were put out by the Climate Prediction Center under NOAA. So these were put out about a couple weeks ago. So this is for the whole winter 2018-2019. So for South Central Alaska, I like how Alaska is sized appropriately compared to the rest of the lower 48. But so the CPC is saying that there is an above average chance that we're going to have above average temperatures. So if that makes any sense to anyone. This means that the deck is being stacked towards temperatures being above average, which they have been pretty much for the past year or so across the state as a whole. Precipitation, same thing. We are looking at above average precipitation, or a greater chance that there will be above average precipitation along the coastal regions in Alaska and South Central Alaska. So what's causing this? Well, we have El Nino. I'm sure everyone's familiar with La Nina, El Nino, appropriate Chris Farley, El Nino. If you're not born, if you're born after 2000, you probably don't know who this is. But so El Nino is just, what it really means is the waters in the equatorial Pacific are expected to be above average, which is going to drive kind of some regional weather patterns. Doesn't mean it's actually going to happen, but again, the deck is being loaded that it's going to drive kind of wetter, warmer conditions along the Pacific coast with wetter and cooler conditions along the southern tier of the U.S. So what does that mean for snowpack or the weather in the mountains in South Central Alaska? So I kind of looked into this a little bit. I looked at two snowtail stations, one at Alyeska at 1,500 feet, and the other one was at Turnagain Pass at 1,800 feet. And I wanted to see what did the SWE, or the snow water equivalent, what did that look like throughout the year during El Nino events. So here's a weak El Nino event, and we are expected or forecasted to be into a weak or moderate El Nino this year. So as you can see, we're kind of across the board here with total snowpack for Alyeska. We got some years with a weak El Nino where it's well above average, other years where it's below average for most of the year. So not a whole lot we can gain from that. Looking at a moderate El Nino, same thing, and a strong El Nino, same thing. It can be well below average or well above average. And notice our last strong El Nino was 2015 and 2016 at Alyeska, and that was a pretty dismal year, well below average. I'll talk about that a little bit later. One thing I did notice though was if you look at all the El Nino events since 2000, it doesn't look good for Alyeska. Almost every single year that there's been an El Nino, the snowpack has been below normal, below the median for that year. So you can kind of take that with a grain of salt. If you're skiing at Alyeska, maybe it won't be as good as it has been, as it was last year, or maybe the 2011, 2012 year. So let's look at Turnagain Pass. They have a pretty similar SWE profile throughout the year, peaking at about 40 inches. So here's a weak El Nino, all below average. Moderate El Nino, now we're seeing some years that are getting above average. And a strong El Nino, all above average. So if you look at going from weak to moderate to strong, you notice that the SWE is actually going higher and higher and higher. Now why is that different than at Alyeska? From what I can tell, it looks like because Turnagain Pass, the snowtail station, is a little bit higher, it could mean that because they're higher, they're more in the snow line, above the snow line than Alyeska is. But that's just my theory. Something that actually might drive our weather more than El Nino, than the waters in the equatorial Pacific, is the waters closer to home, the waters in the North Pacific and the Gulf of Alaska. So there's this thing called the blob, and what that is it's an area where the ocean temperature is above average in the North Pacific and Gulf of Alaska. And you can see this is a prediction of sea surface temperatures, sea surface temperature anomaly for the next 3 months, so from November through January. And they're all showing a nice area of 1 to 2 degree above average temperatures in the waters surrounding Alaska. So that is going to have a much more likely impact on our weather and our snowpack than El Nino or La Nina will. If I go back to the slide, if you think about it, if we have a North Pacific storm track that's coming up from the south, it's going to drag warmer and wetter air into the mountains, and it's going to tend to increase the temperature, tend to increase the freezing level, and tend to increase how much precipitation we get. But if we do get a storm track that comes from the northwest or the north coming off the Arctic, well, that's going to change. So really this is all dependent on the storm track. So generally speaking, conditions, we can expect it to be warmer, or at least the deck is stacked that we are going to have warmer conditions. Doesn't mean it's actually going to happen. It's going to be wetter. And snowfall is going to vary more with elevation, meaning you're going to have a stronger gradient with elevation, how much snowfall you get. And that we kind of saw that in the 2014-15 season and the 2015 and 16 season, where we saw pretty much grass at sea level, and then as you go up above 2,000 feet, Alyeska, I think, had over 800 inches of snow. So a huge gradient in snowfall. And again, it's all dependent on the storm track. If we get a persistent storm track that comes out of the northwest or the west coast, it's going to be completely different than if it comes from the Gulf of Alaska and brings up that warmer, moisture air. So, but in reality, forecasting seasonally on a seasonal time scale in Alaska is really like throwing darts. Sometimes you might nail it, other times you're not going to get it. So it's hard, and forecasting on a short-term scale is difficult, but trying to extrapolate that into months or seasonal is very difficult. So all we can do is give our best approximation and hope it works out. So that's all I have, and you guys have any questions? Hoots.
Could you give us a brief education on the PDO?
Pacific Decadal Oscillation. I'm not 100% up to speed on the PDO because I've been studying mostly the ENSO or El Nino La Nina, but I can talk to you later about that if you want.
Okay.
Thanks. Any other questions? Yep.
Do you guys have any change to the products that the National Weather Service has been?
Oh, that's a good question. No, everything is still pretty similar. So we are producing a rec forecast that started a couple weeks ago. So the rec forecast is kind of a summary of the mountain conditions, 24-hour, 30-hour forecast for Turnagain Pass, Hatcher Pass, and Thompson Pass. So that's produced twice a day, updated twice a day throughout the year. So you guys can get that from our site, and we actually have some flyers at our table if you guys have questions about that. And there really aren't a whole lot of changes to our other regular products. So thanks. Sir.
Do you have any data that shows the strong El Nino year with the water blob?
That would be the 2015-16 year. It was a good example of that. I don't have more data than that to look at, but that year, as we saw, really warm in North Pacific and a really strong El Nino. So waters over the whole Pacific were warmer than average. And so we had a lot of warm, wet storms come up that year. And the snowpack, way up high was super deep, but down at sea level it wasn't nothing. So yeah, I think our seasonal snowpack is driven more by the blob than El Nino or La Nina. So, yes, sir.
How much does ENSO affect the polar jet? And if it doesn't, what is the biggest driver? And are there any sort of models out there?
I'm not 100% sure on how it directly impacts the polar jet, but it does definitely impact more of the subtropical jet, which can indirectly cause the polar jet to shift in different ways. So with the El Nino, the subtropical jet is going to be aimed more at the west coast, and you're going to have more of a southerly flow along the west coast, which brings us, warmer and wetter conditions. But how that impacts the polar jet, it's not really understood. The polar jet could be almost independent some years. Other years, it can be directly impacted by the subtropical jet.
It sure seems like the polar jet has, that could change all the kind of the Southcentral weather
Yeah.
that we get.
Absolutely, yeah. If you have a polar jet that's dropping down from the Arctic, that's going to block the storm track from going from south to north, and bring your cold air down from the north instead. But how that's impacted by El Nino, La Nina, it's not really clearly understood, since it's not directly related to each other. So, good question though, thanks. Yes?
Are we seeing the temperature anomalies being calculated as the difference from average or normal? Are we seeing those averages creep up with a lot of years?
Yeah, it's a good question. So the averages are calculated on a 30-year moving average. So right now, the averages are from 1981 to 2010. So we're about to enter a new decade. So we're going to move, the 30-year average is going to be from 1991 to 2020.
Okay,
So it'll shift.
you do it every 30 years. It's not like every year.
Every 10 years, it'll shift up 10 years. That makes sense. So we're about to move into a new 30-year average period in a couple of years. So I would expect that 30-year average to now be higher than it was before. So, anyone else? Okay, if you have any other questions, we're at the table over there, and if you want to pick our brain, feel free. Thanks.